but as in like from your understanding of experience and how the field is progressing, do you think large models are going to be there for a long time, or is it something that like we are not improving the architecture per se, but we are just expanding the architecture versus when we have these bigger data sets? So in terms of your own experience, what do you think? Like, would large models really solve the issue, or do we have to really think in a very architecture efficient way in order to solve these problems, like let's say multimodality and lots of other problems that we have? What has been your experience so far, if you can share?
Yeah, that is an interesting question. Very tricky. I would say right now, I mean, the recent success of these big models, I would say it justifies looking more into it and doing more research on that. But then at the same point, it's like, where do we stop? Where do we draw the boundary? Because the models become so big that we can't really use them anymore. So how does it help us if we have big models that we can't really use anymore? It goes also a little bit to or the direction is like, what do we want the model to do and where do we want to do it? And I don't know. So if you have like a smartphone and you want to have a prediction that should work offline, so it has to be on the phone, so whatever algorithm. So maybe in that case, well, these big models are useless because they're too large for running on a phone. So in that case, well, that's maybe not what I want. But if I am Google and I want the best possible, let's say, query for search, maybe you run this on a big server and this is okay. I mean, so it really depends. I think there's no one size fits all solution. I think every model has its place. One thing I should say though is yeah, these big models, they require a lot of resources to train, but you don't necessarily have to train them always from scratch. This is like I think the premise behind it, that you can train them on a general purpose data set and then you can fine tune them. And yeah, in my book, in the transformer chapter, we did that with the BERT model. The BERT model, by the way, it was too big for the GPU memory. So I used distill BERT, which is like, so distilled version is like a version that is a little bit pruned. It has fewer parameters, but has almost the same performance. And yeah, I was fine-tuning that on that IMDb movie dataset. The performance was better than with a recurrent neural network, but I think it took multiple hours to train, and the RNN took 5 minutes to train, which is also one thing to consider, right? So you get maybe 3-4% improvement on that data set, but at what cost? At like 3-4 hours instead of 5 minutes. It's like so much more expensive. And I feel like, yeah, depending on what you want to do, I wouldn't say they solve all our problems, especially when maybe it goes towards like new data sets that are, let's say, very different from the data sets that the models were pre-trained on. There's a chance you can still fine-tune it, it performs well. But yeah, I wouldn't say, I think it's interesting and important to go into this direction. Let's see what happens. But I think other models still have their place. And I think we are just right now a little bit, I would say, stuck with existing methods. So SVMs, random forests have been around forever. 20 years, and there are still sometimes a research paper that makes a little improvement, but it's really like, I would say, the low-hanging fruit in that area has been harvested. And the same, I would say, maybe not so much, but the same is somewhat true with CNNs. I think like 5 years ago, we had a new architecture every month that was like groundbreaking. Now, yeah, we still have new architectures, but it's a bit slower, right? So in that case, people are looking for, let's say, something new to explore, and transformers are just right now the thing. At the same point, I think as soon as someone finds a non-transformer model or method that is, let's say, cheaper, I think everyone would be super excited. So I think right now, partly people work on these big transformer models because they are the best we have, but I don't know, maybe I'm wrong, but I don't think anyone is happy about the fact that they are so big. I think everyone would wish they would be smaller, and as soon as something comes along that is smaller and, let's say, better performing or even similarly performing, like a new architecture, I think everyone would be super excited and jump to the new architecture. But it's just my thought or my thinking.
Yeah, no, I mean, to me, it makes sense. I mean, it really depends on the application. Like, if you are focusing too much on the very minute details of accuracy, like you said, big firms like who are very heavily invested in like even the minute improvements, they don't care about computation resources. For them, large models in general would be a good fit. But for people who just want a proof of concept or just want to try out a different technique in order to solve the problem, for them, it would be still focusing on like you already mentioned, like if you had the option of using recurrent neural network, if the performance drop is not much of a big issue, then I think they would stick with recurrent neural network rather than going to fine tune birds. So yeah, that makes a lot of sense.